let's focus on setting up Apache with SSL or Secure Sockets Layer support. So Apache with SSL support. And the acronym is self-explanatory, but let's list anyway what's provided. And that is secure communications, secure/encrypted communications. And there are many requirements that need to be in place, some of which or most of which are already in place, but we should list them nonetheless. They include HTTPD, meaning the Apache web server, which is already installed, OpenSSL, which is the Secure Sockets Layer library, which is also installed and is used by other packages like SSH, Mod SSL, which provides Apache with hooks into the OpenSSL toolkit, which is not installed, and Crypto Utils, which provides the GenKey utility, which is now a curses-based utility. And GenKey is used to generate certificates / private keys, as well as CSRs, or certificate signing requests, that you can then send out to an authority such as Thought, VeriSign, to have them sign for you, or you could use GenKey to self-sign a certificate. So we should also note, also used, which we'll be using it for, to create a self-signed certificate, which you can then use to start Apache with SSL support. So let's recap. You need the Apache web server, you need OpenSSL, Mod SSL, and Crypto Utils. With that said, our first task is to install the requirements or missing packages, including Mod SSL and Crypto Utils. Let's navigate to the shell and execute a yum on the remote system, Linux CBT serve 4. Install mod_SSL. And it's not SLL, but SSL. This will search the package repository for mod SSL, and it will set up any dependencies. Now, once installed, an RPM query list mod_SSL reveals its contents, which includes the SSL.configuration file that Apache will use. So this provides the hooks that Apache needs, the appropriate directives, which include ciphers and links to the certificate and private key files, amongst other things, as well as a module that Apache loads. We did mention that Apache is modular. Well, Mod SSL is a plug-in module for the Apache web server. So this is a module for Apache which provides SSL support. And we've installed it using yum-y install mod SSL. Additionally, we should install Crypto Utils to be able to generate self-signed or CSR-based public key private key pairs. So it's yum-y install Crypto Utils, which will get this from the repository as well. Once it's installed, we'll RPM query list crypto-utils, and it includes the following. It's primarily Perl-based, but the primary utility is GenKey. So Crypto Utils provides GenKey. That's the key utility. It sets itself up in user bin, and it has documentation and other Perl links to help it do its job because it's a Perl-based application. So we've got both Crypto Utils and Mod SSL installed. We should just confirm quickly that OpenSSL is installed using query all grep I OpenSSL, and you'll see momentarily that it is, and there it is. We don't need the development OpenSSL package, simply the OpenSSL primary package, and we know that Apache is installed, so no need to check on that, but we'll check it anyway. So with that said, we have all of the prerequisites. Next step to move forward, before we generate the usage keys, let's show you the trace, the SSL.conf file beneath the top-level server root directory etc httpd, let's navigate into conf.d. We will see a new entry named ssl.conf. This file contains, again, the key directives to turn on SSL support, including the fact that it must load the module, SSL module. From the module's symlink, you'll find, or in the module symlink, you'll find mod_SSL. It has a listen directive instructing the server to listen to port 443, the SSL port. And it has additional settings pertaining to application types that are to be served for X509 and PKCS certificates, CRLs versus CRTs. And this is the certificate revocation list versus the cert itself, the public key. Built-in passphrase, cache information, random information. The crypto device is built in. A default virtual host container, which contains its own reference to error and transfer logs. It logs at the level 1. It's all self-contained, so this will be a default virtual host, meaning bound to the default IP address of 199. The SSL engine is set to on. The protocols supported include all but can be restricted depending on your needs. Cipher Suite includes various protocols supported by various browsers. The certificate file, this is the public key. This is one of the key directives that we'll need to update after we've generated our key pair. And this is the public key portion of the private key public key pair. It references a dummy key named localhost.cert. And this is located beneath etc PKI TLS. So mod_SSL provides etc httpd conf.d ssl.conf, which includes directives. So this includes key SSL directives, including where to find the public and private key pair. And here we see the reference to the key file, which is a private key of the public key private key pair. And many of the other options are turned off. We see a reference to a CGI bin directory, a files directive that's regexed out to different suffixes, CGI, SHTML, so on and so forth. And towards the end, the file wraps up and the virtual host container is closed. So the SSL configuration file is ready to go. However, we have not generated appropriate usage keys. We did copy and paste the path to this key, which is a dummy key, which can be used to service requests, but it isn't a key that we should use on our server for production purposes. We should generate either a key to be signed, which means we'll need to generate a CSR, or a self-signed key, which means you don't need a CSR. So step 2 is to generate SSL usage keys using GenKey. Now we'll use GenKey followed by the name of the domain, GenKey, and we'll tie it to one of the sites, such as site1.linuxcbt.internal. And this will generate a key with site1.linuxcbt.internal fqdn in the key name. It'll be tied to the key. Key pairs have DNS host names, or FQDNs, built in. When you make a request for a key, when you generate a key pair in a CSR and you send that CSR over to a CA such as VeriSign, it is expected that your request contains an FQDN that you control, such as site1.linuxcbt.internal. Let's go ahead and execute the GenKey. And by the way, before we do, let's just execute which GenKey. You'll see it's in user bin. Anyone can execute it. Anyone can generate a key pair, but not anyone can update the Apache configuration. So with that said, let's try to generate it. And it propels us into this interface. It accepts the argument from the command line as the name of the public and private keys to create. So you're now generating a key pair which will be used to encrypt SSL traffic to the server named site1. So it's tied to this FQDN site1.linuxcbt.internal. It also tells you can optionally create a certificate request and send it to a CA, such as thought. The key will be stored beneath etc PKI for public key infrastructure, TLS, transport layer security, private for the private key, which is terminated with a suffix of .key, and simply certs for the public key, which terminates with a suffix of .cert. So let's navigate to next by pressing tab and then pressing enter, and then we need to determine the bit strength of the key. 1024 is currently the accepted standard, but you could, if you'd like, generate a higher standard key. The higher the bit depth or length of a key, the more resources are required to encrypt and decrypt communications to and from your server. So we'll stick with 1024. We're using this internally, but you could alternately indicate a different bit depth. And this will generate the key based on any amount of entropy you can find. So when you generate keys, move the mouse, toggle the keyboard, do things to supply the process with entropy. The more entropy or the more randomness the process has, the more unique your key will be. So we've launched GenKey, and this creates ncurses or text GUI interface, which allows us to generate the key based on the name supplied at the command line. Again, entropy, entropy, entropy. Supply it with entropy. This is just like generating a key pair using GPG with the GenKey option. It requires randomness, and the more randomness, the more unique the characters are used in your keys, both public and private, which increases the strength of your key or decreases the likelihood of the key being cracked. And this is pretty much at the 65% mark, so we should be there momentarily. While the key gets generated, let's just recap. In addition to the Apache server, you must have OpenSSL, ModSSL, and crypto utilities. Crypto utilities is optional if you have a key pair already and would like to use that key pair, but chances are you don't, and chances are you can always make use of the GenKey utility to generate a key, either now or later when your existing key expires. So here are the packages you need to be successful with setting up Apache with SSL support. And in doing so, an SSL.conf file will be created, and it contains directives that will cause the server to listen to port 443 and to bind the SSL instance to the default virtual host, which gets tied to the default IP serviced by your Apache instance. Once we've executed the GenKey process, it'll create the keys beneath etc PKI, TLS, certs for public, and private for the private key. The next step is to update etc httpd conf.dssl.conf to reference the new keys. But we're not at that step yet. We are finishing up. Now here we have the option to create a CSR, or certificate request, a signing request. We don't want to create a certificate signing request because this key is tied to our fictitious internal domain of linuxcbt.internal. So we'll indicate no. And by doing so, we're propelled into an interface to create a self-signed certificate, at which point we should indicate a country code, followed by the state or province, followed by the locality, and the name of the organization. Optionally, you may specify the organizational unit. We'll call it development. And importantly and mandatorily, you need the FQDN. This will be tied to the key. The key will work properly without throwing an error to the user if the user makes a request to site1.linuxcbt.internal. Let's tab to next, and we have the option to encrypt the private key. This can prove painful if you're not at your server or have SSH or some sort of means of connecting to your server every time Apache is restarted. So we elect not to encrypt the key. Encrypting the key means assigning a passphrase to the key so that only when the passphrase is supplied can the key be used. It is indeed a more secure way of operating in a PKI world, in that if your system or your keys have been compromised, unless the person or the unauthorized person knows the passphrase that's used to unlock the private key, they'll be unable to use it. So it adds another level of security to your private key public key pair. And it's important for high security environments that you do encrypt the private key. But for our intents and purposes, it's unnecessary. So we'll enter to move forward. Now with that said, we can confirm that the keys have been generated. Let's lsltr/etc pki tls certs, and that's the CERTS directory. There is the public key for site1.linuxcbt.internal. We'll just copy this into memory because we'll be using it to update the ssl.conf file momentarily. And let's take a look at the private directory where you'll find the private key, which we should guard and has very limited permissions. Root can only read the file. And with that said, let's modify the ssl.conf file. The gen key utility, and you'll see momentarily when we get to the SSL cert file option, does not update the public key private key references. So we'll change from localhost key to the public key for site1.linuxcbt.internal, and we'll also update the private key reference file, which we may have passed. Let's just go up. It appears as though we have, so let's find where the .key file is referenced above in our dump, and there's the certificate file. So we overwrote the wrong one. This is the key file. So this is the public key file, which we need to update. Certs, and this one needs to be .key. This is the private key reference. Now we save the changes. So we've updated ssl.conf to reference the new keys, meaning both public and private, or PKI, public key private key pair. The next step for us is to restart the server, or start it if it's not running. Restart, which implies start the HTTPD server, and of course confirm that SSL support has been provided. So service HTTPD restart followed by HTTPD upper S will reveal SSL specific info for the virtual host that it's tied to, of course. Let's give this a try. We'll echo the exit status to be sure it's been clean, and then HTTPD S. There you see the 443, the lone default virtual host, and it's tied to the server. It's referencing ssl.conf, and the syntax looks okay. Also, a netstat NTLP grep 443 will reveal that Apache is listening to 443. So then our fifth and final step is to test connectivity. Of course, it'll throw us errors because it's self-signed, but it'll still allow us to connect using encryption. So, test HTTPS connectivity, of course using a browser. And that will be the default IP address, or the IP address that's used by the default host, which is 199, and this will do the trick. So let's open a browser and try to hit the system. And we may optionally update our DNS so that site 1 points to the 199 IP, and that'll be fine. So now this is going to hit, or attempt to hit .199 using HTTPS, and because it's a self-signed key, we're prompted by the web browser to accept it manually. You may examine the certificate to determine whether or not you'd like to accept the key. Here we see the common name, the organization, the unit, all the information we have inserted. When it expires a year later, or in this case it's a month later, which we could alter, and it was issued today, and so on. The SHA and MD5 fingerprint, and it's a self-signed certificate. So we can determine that we'd like to accept this key, and then we will be redirected to a secure session. And it says you've attempted to connect to this, but the security belongs to site 1. So we need to be sure that DNS points site 1 to the appropriate IP address. But what's more important is that now we have a secure sockets layer connection to the remote system, and it tells you who it was signed by, and you can double click to get more information about it. We're using AES 256 high-grade encryption, and now users in between will be unable to sniff our sessions, or they'll be able to sniff it but not make sense of the traffic. So again, as far as site 1 is concerned, if you ping C3 site 1 and the domain name, you'll see where it leads to, and it doesn't know, which means we either update DNS or update our hosts file to include the IP address of site 1. And this is the full name followed by the short name. Now when we re-ping it, it will respond, sending 3 ICMP packets and responses. And now from the browser, if we HTTPS site 1 internal, then it will take us to the server, and it tells us we're leaving an encrypted page to hit another encrypted page. And now it attempts to hit site 1. Now, site 1 returns an error because site 1 is handled via virtual hosts. So because of that, it doesn't know where to find it. And in fact, it says server not found. In this case, the server is not throwing the error. This is the client not knowing how to get to site 1. Let's double check that we haven't misspelled. We'll return to the shell, and we in fact have updated site 1 on the remote system. So we haven't actually hit the browser, the server that is. It's all locally that these problems are surfacing. So let's modify etc hosts and create the entry locally for 75.199. And it's site 1. We'll save the changes and exit, and then ping C1 from this system, site 1, and that's more like it. So now we'll refresh in the browser, and that's more like it. Notice more errors. How about closing the browser altogether, which will cause us to have to accept the certificate once more, either temporarily or permanently. And now let's try to hit it again, site 1, and it's going to communicate with the server momentarily and make the determination as to whether or not we trust the self-signer. We'll accept it temporarily, and now we have an SSL session. So setting up SSL is straightforward. Let's just recap the steps. Ensure that on Red Hat Enterprise 5 these 4 packages are installed: Apache, OpenSSL, ModSSL, and crypto utilities. Then generate usage keys. If you don't intend to have the public key signed by a certificate authority for actual production use on the internet using a real domain, then self-sign the key by electing not to generate a CSR. That causes the gem key utility to self-sign the key, which prompts you, of course, for useful information such as country code, locality, etc. Update the ssl.conf file to reference the new keys. Restart Apache and then test connectivity. Now you may be wondering, what about SSL for multiple IP addresses or multiple vhosts? For those multiple IP-based vhosts, and note IP-based vhosts because the support is limited to distinct IPs, simply create distinct ssl.conf files per IP-based virtual host. Let's just note that for multiple SSL sites, copy the etc httpd conf.d ssl.conf file to distinct files that match your distinct IP-based vhosts, and then follow the remainder of the steps, and you'll have SSL support on a per IP-based basis. So it's really straightforward to impact SSL configuration within Red Hat Enterprise 5. Now, one other note before we move on is related to the 30-day key that was generated. If you recall, our key that's currently in place is good for 30 days. If you double-click on the lock in the browser and examine the contents of the certificate, you'll see that it's only good for 30 days, from the 25th of January to the 24th of February this year. When you use GenKey and you specify a given FQDN, you may also indicate the number of days the key should be good for. Execute GenKey --help and you'll see that one of its options is the number of days, with the default being 30. So set days to something reasonable, such as 365, 180, or what have you. And with that said, you'll be able to generate a key or usage keys, public key, private key pair, based on any number of days. The default just happens to be 30 days, which is why we were not able to influence the number of days when we set it up for site1.linuxcbt.internal. So we'll continue our studies of Red Hat Enterprise 5 in subsequent sections.